Okay, well, thank you very much for giving me the opportunity to come here and say a few words about this. I've tried to concentrate on the European situation in this presentation, although this is my 41st year in climate change science, so that'll give you an idea that I'll probably stress Australia and I'll probably stress the climate change issue a little bit more than anything else. What I will do is to talk a little bit about the finite world we live in, because one of the issues that is fundamental to this is that actually the world is finite, and we can't do everything that we would like to do. We run into some barriers. I'll try to talk a little bit about the European circumstance with regard to environmental and climate change issues. Then a little bit about lessons from sustainability. And I'll finish off with a bit on myths and prejudices, and this comes out of the fact that over the last 5 years I've worked a bit with psychologists, some of them from Monash University, trying to understand after all those years in climate change why no one's really listening. And I'll try to give you a feel for where I stand with regard to that at this stage. The reality is, of course, as time is going forward, and the timescale on this bottom here is from 1750 up to the year 2000. A whole pile of things are changing. We have some major drivers. The population has changed dramatically. I haven't put scales on these because it's really irrelevant. Just simply saying the population is going up, GDP is going up, foreign investment is going up, and there are demands that are going up, like motor vehicles, power, paper consumption, forestry exploitation, water use, and many others. And these have impacts, and some of these impacts are now being felt globally. And if you sit down with these slides later, you'll be able to work out which colour's which. But amongst those curves going up is the CO2 concentration, temperature of the northern hemisphere, as it turns out in this plot, ozone depletion, species extinction, loss of tropical rainforests, and so on. This is a little bit like the sort of limits to growth concept that came out many decades ago. In fact, it's been reviewed by several organisations in the last year or so, suggesting that in fact they weren't as outlandish as people thought actually for the next 30 years. We have a number of things that are happening. This is the temperature of the planet. It fails. I had a quick look yesterday when I put these slides together to see whether I could put in last year's data, but I wanted to do it from 3 data sets. These are 3 independent organisations that try to make an assessment of the global mean temperature. But all I can say is that if I had 2011, it would be down. Wouldn't be continuing up, it would be down. And that's because 2010 and 2011 and 12, were both La Nina years. And almost every one of these dips in the past is a La Nina year. And that has a global impact on the mean temperature. It's just a state of the climate system that occurs every 7 years or something like that. You've probably heard of El Nino. It's the opposite. So these peaks are El Nino years. The point about this, of course, is that many people, and you'll see it in the newspapers in the last week, saying, well, it stopped warming. And the reality of this data set shows that the variance of annual mean temperature of the planet is about plus or minus 1 to 2/10 of a degree. And if you have that variability, then you have a trend that is about 1/10 of a degree per decade. With a decade's record, you won't see it. You'll never see it. And that's, you can pick up these parts in this. There's really no evidence, because if you look at the mean temperature of the oceans, which don't have as big of variations because of the thermal capacity, you don't see any drop. It just simply goes up. But anyhow, that's the warming of the planet. associated with that, because when you warm the water expands and the sea level goes up. It's not the only reason, but that's actually the primary reason up to now. The sea level's gone up about 20 centimetres on average. This means that it creates a situation, as with the temperature, that the probability of getting an extreme sea level event or an extreme temperature event, like will happen in Adelaide, I think today they're projecting this, is raised very much. By moving the mean a little bit, you change the frequency of extremes a lot. Or if you look at sea ice extent in the Arctic, and I'll get to the relevance of this to Europe in a moment, is that this is actually what happened last year to the extent of sea level in the Arctic. It's been coming down. This is the average here from basically from 1980 to 2000, and then we've had these drops, particularly in 97 when we thought that was the worst we were going to have, and then it's gone down again. There's no surprise then that Canada, the US, China, Russia, Norway, and other nations are all very, very active in the Arctic, because this region, of course, contains huge undersea resources that people would like to get to, but it also can potentially change the dynamics of how communication takes place between those nations if we leave the sea. In 2007, when the Intergovernmental Panel on Climate Change reported on this particular issue, they projected that the most probable time when we would lose in 1 year all of the ice in the summer, it would be about 2050. And most projections now it's possible that in the next decade, because all of this change has gone a lot faster than we thought it would. So let's now get back to the more general theme, and that is sustainability. This paper in 2009 was an attempt by a list of about 12 authors to say, well, are there limits to some of these things? And they tried to, this shows you in a circle, which is the safe operating space. In other words, we can perturb some of these global systems by a certain amount, and we think it's safe to do so within there. But if we go outside of those limits, then we are actually starting to compete with the natural flow of energy or materials within the system. For example, this is phosphorus cycle. This is the nitrogen cycle. The red bars are where we're at. So for this cycle, the nitrogen cycle, every indication is that we've massively changed the nitrogen cycle of the planet, much more than natural variability, and similarly with biodiversity loss. The biodiversity loss is way outside of the natural expected loss of vegetation. Now there are other things that have been analysed here, like atmospheric aerosol loading, how much dust there is in the atmosphere. That hasn't been assessed. We don't really know for sure about that. Ocean acidification, as we put carbon dioxide in the atmosphere, dissolves in the ocean and acidifies the ocean. And here's the bar starting to come out now, and we think that we can go out to here before we start to actually go beyond the safe operating space. So conceptually, this is an attempt in many ways to counter what for many of us is a fairly strongly internally accepted belief, and that is that somehow Mother Nature cannot be violated. It is so huge, so enormous, that what we do as a mere species cannot actually upset that. And these are indications of where that's not the case. This is another one, and I don't want you to quote these because they're unpublished, but these are my own calculations, and I was talking to you about this just before. That if you actually calculate the energy, compare the energy consumption that each nation listed down here actually has, and compare that with the energy that's captured by all of the photosynthesis of all of the vegetation of those nations, then you find that for the US and China, it's 100%. All this natural variation, all this natural vegetation only captures about the same amount of energy that we're using in those countries. If you're in Singapore, because it's a small country, affluent, a lot of energy, it's way out. There's no way they could ever actually access the energy that's in the primary production to use to counter their use of energy. And I would argue there's no way you can do it here either, because you have to have massive changes to natural vegetation. In fact, I would argue you can't do it here in Australia, because you would have to actually capture 10% of all of the new vegetation produced each year by all of the ecosystems of the whole of the country with 100% efficiency in order to cope with our energy demands. This is not a proposition that's real. There's a severe limitation, but what happened in the limitation here is how much solar energy falls on each country, and secondly, the inefficiency of the photosynthetic process. Yep.
Are you including agricultural crops in that, or is
in
it
this
just...
case, yes, but I've actually done these figures for agriculture, and it turns out that agriculture, in terms of efficiency at producing material per unit of area, is actually not that much better than the natural vegetation. It's slightly better, particularly for sugar, but not much better. And there are a number of reasons for that. Okay, so what about the European experience? Well, the models, climate model projections that came out with the Intergovernmental Panel on Climate Change, Chapter 11 in 2007, and I probably won't come back to this, but the Intergovernmental Panel on Climate Change is a group of scientists around the world that actually periodically, every 6 years or so, review the published material. So they don't do new research, but they assess what all the new research is saying. And the next review from the Working Group 1, which is the physical science, will come out in a few months' time. Some of you may have seen in the news in the last day or so, a meeting in Hobart, where some of the scientists are trying to get together and finalise what they're writing in their document. This is what is projected for the June, July, August, December, January, February period for the globe in terms of precipitation changes. And for those of us here, we are very familiar with this. But the two semi-arid bands of the world that are there because of subtropical subsistence of air are expected to increase in their strength, leading in both hemispheres to greater aridity in this region. And I'll show you this for Europe in a moment. Here in the southwest of Western Australia, we saw this commence happening in the 1970s. And we now have about 15 years of evidence of it happening now in the eastern part of the country as well. And there's a lot of ways of looking at this. You can look at when you look at precipitation, it's so variable in time and space, it's not a very easy way of looking at it. But if you look at, for example, at the mean pressure, atmospheric pressure that lies over these regions, you can see it increasing and shifting poleward, which is exactly what the theoretical model suggests. So this is the best estimate of rainfall. This is the best picture I could get. It's a bit fuzzy. But I wanted to point out that what it shows is that for the Mediterranean region, just as for the southern part of Australia, the anticipation is a loss of rainfall. And up here in the north, quite the reverse. And these are big numbers. This is actually for a long time in the ahead, but it gives you an idea that we're talking up here about increases of the order of 20 to 40% in rainfall in places like Norway. This is a huge change. No vegetation, no river system, no water catchment system or anything will remain the same with those sorts of changes, just as there will be changes down here. And there are, of course, temperature maps that are similar to this. The other way of looking at that, this picture is for 2020, not so far ahead. This is for 2070. The A2 refers to some assumptions about how much carbon dioxide will grow in the atmosphere, but showing the net result of that, which is not simply how much rainfall you lose, but it's a combination of effects on rainfall, temperature and wind speed, is the available water, the runoff, the moisture that actually gets caught in soil. And so for Southern Europe, it is an indication of increasing aridity with an improvement of runoff in the northern part. Or should I say an increase, because greater amounts of things are not always necessarily improvement. And within the IPCC, and you can go to their website and get some of these graphics if you wish, this leads to a number of suggestions about vulnerabilities within the European region. Clearly, across this area here, associated with this loss of water availability, reduced water availability, and I'll read these because you may not be able to see them, increased drought, severe biodiversity losses, increased forest fires, sound familiar? Reduced summer tourism, there's a whole pile of potential impacts that flow on from the fact that the environment is no longer the same in these regions as we go forward in time. The light blue area here is an increased coastal erosion from flooding, because the sea levels have gone up, but more important than people concentrated is it going to be 50 centimetres, is it going to be 90 centimetres? Pretty irrelevant, because the fact is exposure here in Melbourne will be one extreme event that will occur. This probability of occurrence is probably now higher because the sea level is higher, but also because the high pressure belts have shifted and the climate system has shifted, that will actually cause millions of dollars of damage around the bay here because we're built. I come from, used to live in Aspendale, and most of the Aspendale beach now is sandbagged. This is not a coincidence because those beaches are eroding. But it has relevance to what you were talking about before, and that is that in other parts of the world, in not too far from Europe, there are huge numbers of people who are threatened by this. And so the issue of migration, forced migration, is another issue that needs to be considered. What happens if we do lose or make vulnerable millions of people, say in Bangladesh or some of these low-lying countries, where the countries themselves don't have a lot of capacity to actually respond to a disaster like that? How will that impact? Well, I don't know the answer to that, but they are the sorts of things that policy development needs to consider. The decreased crop yield, increased soil erosion here, right through here, increased frequency of winter floods, because we're now going into the region where we're getting more rainfall, but particularly in this lower part of the winter. And here, waterlogging, eutrophication of the lakes and wetlands, increased coastal flooding. And right up here, getting back to the ice issue, is thawing of permafrost. And of course, one of the big unknowns of the climate change issue is if the permafrost thaws, what gases actually does that release out of the soil? And we don't really want to know that. We really want to know it, but it may not be a good news story. We don't have that information. Now, I wanted to stress that, of course, in looking at this kind of issue, that is the climate issue or the environment or sustainable issue, it's not just about the environment. Somehow or other this has to be included in a much more comprehensive view of all of the other things that we need as a species to be considering. And so there are a number of so-called grand challenges that have been put out by the EU, the United Nations, by ICSU, the peak body for the science unions, and many others. And this is a list that's been put out by the Royal Society of London, which is the oldest academy of science in the world. And I'm not going to dwell on this, but just to go through the orange points to indicate that somehow or other, all of this issue about the future of the environment, sustainability of the environment, has to be taken into consideration when we actually have 1.3 billion people living in poverty. And absolute poverty, and we need to do something about that. We need to reduce material consumption. For example, the example I gave before was with phosphorus. We're simply using more than the world can actually provide. This issue about the rate of growth, because one of the factors in terms of demand is how many people we have, the relationship between population and environment, the fact that urbanisation has its disadvantages, but it has advantages as well, and that is that the more urbanised you are, the more efficient actually you can be in using some of these facilities. High quality primary and secondary education. A lot of people don't have access to this, particularly the gender balance issues there. Interaction between consumption and demographic changes and environmental impact. All of those things are tied together, and we need the natural sciences and social sciences to be much closer linked than they have been in the past. And I'll come back to that issue a little bit later on. National government should accelerate the development of comprehensive wealth measures. A whole area that I won't stress much is trying to actually redefine how we assess or measure success of a nation. Currently, we do it by and large by assessing national productivity, economic assessment by and large. And there are many people all around the world working now on more comprehensive systems that look at things like, well, are we actually happier? Are we safer? Some of you may have actually watched, I watched the other night on television a presentation on the hospital in the Bronx of New York. And that hospital was dealing with people who were being stabbed and shot on a daily basis in the Bronx region. And you have to ask the question whether they have it right. If people really want to live under those sorts of circumstances, the hospital is doing a sterling job in trying to deal with the crises that are being developed on a daily basis in that particular environment. So here in a very wealthy country, have they got that right? How do you measure that? How do you actually make an assessment, and how do you set goals associated with that? Collaboration between national governments is needed. That's not necessarily dependent on continued material consumption and growth. And put in there Australia's position with regard to its sale of energy.